Hey guys, before we dive into the Unit 1 notes, I would like for you to space that out. I would like for you to give yourself 5 minutes to really fill out the unit circle. Now, you can't do it within a reasonable amount of time, then please start making flashcards and study. It's super important that you guys can give me the answer immediately. If I said, okay, what's tangent of 11 pi over 6? Or what's cosine of 7 pi over 4, or what's sine of 2 pi over 3. Those should be known immediately for us to be successful in this unit.
Now 7.1, the inverse, sine, cosine, and tangent functions. I'm going to change my color of pen. There you go. So let's review the inverse properties of, I didn't mean to do all of that. Okay, come on. Okay, so all functions have the same properties in terms of their inverses. As you remember, this right here denote the inverse of f. So number one, f inverse of f of x equals x for every x in the domain of f, which is the regular function, and f composed with f inverse equals x as well for every x in the domain of the inverse. So both of those must be true. Okay, so again, if the function has an inverse, and if the inverse is a function, then the composition of the inverse and its regular must be x, and the composition of the inverse and its function must be x. The domain of the regular, okay, is the same as the range of the inverse, and the range of the regular function is the same as the domain of the inverse. So aka the domain and range switch. The graph of f and the graph of f inverse are symmetric with respect to the line of y equals x. That line, it's actually called the identity line. So y equals x is a line, and it just looks like this. All right, so that's the identity line. If a function y equals f of x has an inverse function, so if the regular function has an inverse function, the equation of the inverse function is, as you can see, we're switching here, is x equals f of y, because we're switching x for y and y for x. Now, we want to write it as a y equals, because typically that's what we do in algebra. So we always want our function to be y equals. So y equals, and that would be very confusing with the original, right? Because they're both y equals. So if it's an inverse, then we use f to the -1 power f of x. So if you see this notation right here, that means it's an inverse of the regular. Now complete this on your own and answer the questions on the right. I'm going to start, even though it says that I will graph sine with you. This is why the unit circle is super important, because you need to know sine and cosine, and right now in this unit, tangent of all from 0 all the way to 2 pi. We are going to graph 2 periods. We are going to do 1 period to the right and 1 period to the left. Each period, we're going to divide this into nicely 4 equal quadrants. And no, we are not reviewing these. If you need to do some reviewing of the unit circle, please do it on your own, and you probably need to do it as soon, oops, this is a pi right here. You need to do it as soon as possible, because you can't really pass Pre-Calc honors without knowing the unit circle. We're going to go up as 1 unit and go down as 1 unit. If you don't see me labeling tick marks, and you don't have to label every tick mark, just a couple, so we know how much each tick mark is worth. Okay. If I don't label a tick mark, you should know that it's always 1. So we are graphing y equals sine of x. Sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is going to be -1. Sine of 2 pi is back to 0. And then the negative side, sine of negative pi over 2 is going to be -1. Sine of negative pi is 0. Sine of negative 3 pi over 2 is 1. And sine of negative 2 pi is back to 0. That is how fast I do need you to know all the basic trig values. All right, because we are graphing to full periods, you do need the arrows on the ends. Because we're stopping at 2 periods doesn't mean it really does stop at 2 periods, okay? Now, number 1 in the box to the right, is y equals sine of x a one-to-one? Let's recap what a one-to-one is. A one-to-one function is when it passes a horizontal line test. So I'm going to give you 2 graphs here. One is a parabola going up, one is a parabola going sideways. Okay. So out of these 2, one of it is not a one-to-one. This is a function, okay? This vertical line is a function. This right here is not a function. So this is a function. Okay, this is not a function. Now, but that's okay. We're not just dealing with function, we're doing one-to-one function. Even though if it's a function on this first one, it is not a one-to-one function. So because this one right here is not a function, so I don't even care. But the parabola is not even a one-to-one function, not one-to-one. So what kind of graph are we thinking about if we're looking for one-to-one? Like this. A one-to-one has to be a function first. So I'm going to draw out a cubic. This one is a function, right? It passes all vertical line tests. Now it's also, let me get a different color. It's going to be a one-to-one because it also passes, horizontal line tests. So any horizontal line, okay, that I draw, doesn't matter where, it does not intersect the horizontal line more than once. So a one-to-one, it has to be a function first, and in addition, it needs to pass the horizontal line test. So sine, as you can see, is definitely not a one-to-one because look, I can draw this horizontal line test and it passes a few different times. So it's definitely not a one-to-one. Because your answer is no, we have to restrict its domain so it can be a one-to-one. Now the reason we need it to be one-to-one is because back to the definition of inverse. If an inverse function is not a one-to-one, it's a regular function is not one-to-one, then the inverse will not be a function. So universally, we have decided to restrict, I'm going to erase this, to restrict the domain so it can be a one-to-one. So technically, we can restrict it any how we want, right? We can say, okay, from here to here, that looks pretty darn good, don't you think? Or that, because that's one-to-one. So this piece will be one-to-one right here. Well, another option is, now I'm going to ask you this. Can I restrict it from here to here? Would this piece right here be one-to-one? That would not be one-to-one because if I draw this horizontal line test, it is not intersecting at most one time. Remember, if it's more than once, then it's not a one-to-one. So that's not okay. So universally, as you can see, we can decide to restrict a bunch of different places. But to make it easy on everybody, we have decided to restrict from here just to here. Okay, so just this piece right here. So it's going to be inclusive from negative pi over 2 all the way to pi over 2. Now, if you look at that, another way of writing that restriction is going to be with an inequality symbol from negative pi over 2 to pi over 2. Okay. Due to that restriction, the inverse definition of sine, because sine is normally written like this, y equals sine of x. An inverse function is when we switch x for y and y for x. But we would like to solve for y equals, therefore, we now use y equals sine inverse, which is f to the negative 1 power of x equals sine inverse of x, okay? Now that's really technically not negative 1 power. It's a notation, it's a language that's stating it's an inverse function of f of x. Well, for this function, this is the inverse function right here. We need to state the domain and range of the inverse, and it's super important that you understand this part. The domain of the inverse and the range, let me just write in the domain of f inverse, the range of f inverse. Okay, now the domain of the inverse is the range of the regular. Well, if you look up here, when you agree that the range of the regular sine function is just from -1 to 1, so we are going to write in inclusive -1 to 1. You must know this. The range now of the inverse is the domain of the original. Mind you, the domain of the entire sine function, it goes on forever. So technically that's infinity, right? Like from -infinity to positive infinity. But we have to restrict it. So this is a restriction right there. So that used to be the restricted domain, as you can see the word domain. So that will be now the range of our inverse. So that will be the range of our, bless you. Sorry, that's my daughter sneezing. Okay, let's graph this out. We are now graphing the regular function first, which is this piece right here. And all we have to do is switch it so we can graph its inverse. I'm going to graph the regular part with the restricted domain first. Okay, all you have to do is go over here, label it -π/2, +π/2. At some point, we will also flip it, so might as well go up and do π/2 and go down and do -π/2. Well, pi, it's about 3.14, but if you divide it by 2, so this is about, if you have to approximate this, it's about 1.5, okay? So you don't have a calculator, you don't need an exact value to plot it, it's around 1.5. Now, so if it's 1.5, a 1 unit would be about 2/3 of its distance, okay? So that's -1. All right, here we go. Let's plot the f of x first. I'm gonna pinch it in, and all I'm doing is really copying that restricted piece from earlier. π/2 is really 1, -π/2 sine. Okay, so now curve it correctly. Okay, so this is the restriction piece of f of x. I'm going to use green, and all I gotta do is switch x for y and y for x. And to make it easier for you, I'm going to label this point. This is π/2, 1. -π/2, -1, and 0, 0. Well, when you switch x and y for x to 0, it's still there. Now, I'm switching this, so it's really 1, π/2. Go up. Okay, this is 1, π/2. Let me make my pen a little bit thinner. Okay, and then this is going, oops. Then over here, I will now go -1, -π/2. All right, now curve it the right way. The original f of x equals sine of x is hugging the x-axis. So its inverse should be hugging the y-axis like that, okay? Now remember we talked about the graph of f and f inverse should be symmetrical to that line right there. If I get a different color, I'm going to try to sketch that line for you. So that line is y equals x. So what that means is whatever the y value is, x value is exactly the same. So look at that. So that's mirror image with that line. That's what it means. Now, I'm going to add on one more thing on the inverse of sine. When we put it back to the unit circle, would you agree that up here is π/2, down here is -π/2? The range of the inverse is really this quadrant, which is quadrant 1, and quadrant number 4. Later, most likely, I'm just going to say, okay, what's the restriction for sine inverse? You can spit out quad 1 and quad 4, or you can say from -π/2 to π/2. So now we're moving on to doing or defining the definition of cosine inverse. Similarly, we will start the same way by reviewing the graph of cosine, y equals cosine of x. Sorry. Woo. Okay, so just like earlier with the sine function, I'm going to ask you to graph two full periods, one to the right, one to the left. And remember, you're supposed to be able to get the values for sine, cosine, tangent, cotangent, cosecant really quickly, okay? Just like back in the days in third grade, when you were doing your times tables, you were able to spit out 3 times 8 very quickly. Now, if you're not very good with the times tables, then you're going to have a more difficult time in math later. Just like with the trig unit, or the unit circle I meant. If you are still struggling with that part of trig, I need you to sit down, study it, memorize all of the values on the unit circle. So cosine of 0 is going to give us 1. So for cosine, we will start at 1. Cosine of pi over 2 is 0, -1, back to 0, and back to 1. And then similarly to the negative side of the x value, cosine negative pi over 2 is 0, negative pi over 2 is going to be -1, 0, and +1. And just connect the dots, okay? Oh, come on, cow. Sorry, my computer tends to do that if I'm on a button that it doesn't like. Okay. We'll start with this side. We'll connect all the dots here. Arrows on the end. Just because we're only graphing 2 full periods doesn't mean the function itself stops. Now, similarly to the sine function, cosine is not 1-to-1 because if you look at this, I'm drawing a horizontal line test and it's not passing. Passing means it only intersected at most one time. Because we said no, we have to restrict its domain so it can be a 1-to-1. Universally, right, we can restrict it any way you want. You can restrict it here. We could technically restrict it from here. We could technically restrict it from here. Or we can restrict it from here to here. But that's really confusing to have a different restriction for every person. So what we did was we came together. I need to erase all of that. We came together and we said, okay, oh, come on. We need to decide, like, what is going on in my computer? We need to decide, okay, where do you want to restrict? What do you want to do? So that way, when one person studies math in, let's just say, Vietnam, and one person studies math in America, we would get the same exact answer. So universally, we restricted, I'm going to highlight the restriction part, from here to here. So that, we're going to fill that in, restrict the domain from 0 to pi. Now, if you like the inequality symbol, you can also write it like this, okay? Definition, inverse of cosine. So inverse of cosine is derived from the regular function of y equals cosine of x. And we would switch x for y and y for x. So this right here is the inverse of cosine. But normally, we don't have an equation starting out with x equals. So we go and we solve for y by composing cosine inverse to both sides. So y equals cosine inverse of x. We would use f inverse of x to represent the inverse function, just like that. We also need to state the domain and range of cosine inverse. Domain of f inverse, range of f inverse. Well, the domain of f inverse is the range of the regular. Well, the range goes from -1 to 1. So that's going to be -1 to 1. The range of f inverse is the domain of the regular. But remember, for us to have a 1-to-1, we restricted earlier. So the range of f inverse is now 0 to pi. Now let's connect that really quickly to the quadrants, because in the future, you may just hear me say, okay, what are the quadrants restriction for cosine inverse? Well, 0 is right here, pi is right here, so it's actually in quad 1 and quad 2. So the restriction for cosine inverse would be quads 1 and 2. Now let's graph out our cosine. Here's pi. Here's pi. All I'm going to do first is graph out the original, okay, the restricted piece in yellow right here, and then we're just going to switch the points. Notice how I'm writing 1 right there, because if you think about it, pi is about 3.14, and 1 is about, okay, approximately a third of that distance. So now I wrote 1 right there. That means a pi over 2 is right here. Pi over 2 is right here. Let's go over here and do negative pi. Negative pi. Oops, I wrote negative pi over 2. Negative pi. And that means a 1 negative 1's right here and a negative 1's right here. Okay? Then this is going to be a negative pi over 2 up here. Negative pi over 2 right here. So the first is the 0 up to 1. Okay? Cosine of 0 is 1. Cosine of pi over 2, how about this? I'll label that point too in red. Cosine, this is 0, 1. Cosine of pi over 2, so pi over 2, comma 0. And cosine of pi is going to be negative 1. So here's that dot. Pi, comma, negative 1. Then we want to connect and make sure the curve, okay, just like that. Now the inverse, I'll do it in green. The inverse is going to be switching the points. 0, comma 1 is now 1, comma 0. So this is 1, comma 0. Pi over 2 is now, I'm sorry, pi over 2, comma 0 is 0, comma pi over 2, which is up here. 0, comma pi over 2. And then the last dot, it used to be pi, comma negative 1. So it's now really negative 1, comma pi. So this is the inverse. Now make sure we curve it the right way. So what you want to do is curve it hugging the y-axis, just like that. So the green is the inverse function. The red over here is the y equals, or f of x equals cosine of x. Now ideally we want to see if it reflects about the identity line, which is y equals x. And in the perfect world, if I'm a good grapher, it should be perfectly mirror image of one another. Okay, so the top should be folding. If you fold it on the y equals x, the top and the bottom should line up perfectly. So our third function for this unit is y equals tangent of x. Similarly, let's go and graph out y equals tangent of x. If you guys remember, it's the period for tangent. It's only a pi. So what we want to do is go a pi to the right and a negative pi to the left. We will go high up as 1, as low as negative 1. Half of pi will be pi over 2. And then pi over 4 is how much each tick mark on the x-axis is worth. Now, if you don't remember anything about tangent, because tangent is usually a little bit more difficult than sine and cosine. So go back and review. Tangent of 0 is 0. Oh, come on, computer. Tangent of pi over 4 is the next tick mark, is 1. Tangent of pi over 2 is going to be, if you guys remember, tangent is y divided by x. So if we take 1 divided by 0, that's not going to work. So that's going to be undefined. Then next tick mark to the right, tangent of 3 pi over 4 is going to be negative 1. And back to tangent of pi is 0. Now that's all we really need because as you know, trig is periodic. That means it repeats. So let's plot 0, 0. Tangent of pi over 4, we're going to go up 1. Tangent of pi over 2, if you guys remember, we have these asymptotes. Yes, you have to show your asymptotes. Then we would repeat. Tangent 3 pi over 4 is going to be negative 1. And at pi is going to be 0. Now, if I keep on going, right? So this is 5 pi over 4. Then 6 pi over 4, which is really a 3 pi over 2. If I keep going, I just have to repeat whatever I already had on the other side. So technically, you can keep on drawing as far as you want. And if you look if you can do one period, you can repeat the rest. So here on the left side of 0 is -1, then asymptote. And on the left side asymptote is 1, then 0, and so on and so on. So technically you can keep repeating forever and ever and ever. So I'm going to do all the way down here, okay? I'm going, as you can see, I went a little bit more than one period to the right and one period to the left. No big deal. And if you look at this, our answer to the box is, okay, it's still not a one-to-one, because we said no, we have to make it so our tangent function can be one-to-one. And the reason that we have to make all of our functions one-to-one is so that when we find its inverse, the inverse function will also, the inverse can also be a function. So, as you know, we can technically restrict our domain over here, or in the middle, or on the right, or 5 periods to the right, or 100 periods to the right. But that would be very confusing for everybody. So normally, we agree on just trying to erase the highlights. But every time I do that, okay. So I'm going to erase the highlighting part to see if it lets me do it. Come on. Oh, come on. It deletes my whole graph, huh? Oh, that one works. Oh, okay. Sorry. Okay. So what we have decided universally is just to limit it from here to here. So that's going to be from -π/2 to π/2. Now, if you look at the graph from -π/2 to π/2, and it's undefined at π/2 and undefined at -π/2. So that's why the two values on the ends are not inclusive, which means we would be using the inequality without the equal. So it can be -π/2 less than x, which is less than +π/2. Definition of tangent inverse, which is going to be coming from the y equals tangent of x. We switch x for y and y for x. So this is really technically the inverse of tangent, okay? X equals tangent of y. Now, we don't like the way that it's written. We don't like x equals. So we compose both sides with tangent inverse, and then that will give us a y equals. So here is the tangent inverse of x. Now, domain of tangent inverse, range of tangent inverse, okay? And the domain of tangent inverse is the range of the regular. Well, remember the range of regular, this goes all the way up and it goes all the way down. So the domain is going to be all real numbers, or from -∞ to +∞. Now the range of tangent inverse is where we restricted earlier, which is right here. So that will be from -π/2 non-inclusive to π/2. Let's connect that to our quadrants. Well, -π/2 is down here. We're going clockwise, and +π/2 is up here. We're going counterclockwise. So this is, again, back to quads 1 and 4, which is exactly the same two quadrants as sine inverse, except that tangent inverse will not have the inclusive on the endpoints. So let's go and sketch out our inverse really quickly. All I need is 0 all the way to π/2, okay? π/2 is here, π/4 is here. At some point, I'm probably going to π/2, π/4, π/2, π/2, negative, π/4. Okay, so those are my pi's. Okay, now I also need 1. So π/2, pi is about 3.14, which is about 3 divided by 2, so it's about 1.5. So if I need to do a tick mark of 1, I'm just going to do about 2/3 way up, like that. Okay. All right, let's sketch out the original piece for tangent, the yellow highlights up there. You will have asymptotes here at π/2. You have asymptotes here. It's easier to graph the original and then just switch the points. 0 is at 0. At π/4, I'm going to go up 1. At negative pi over 4, I'm going to go up to negative 1 and sketch. There you go. This right here in blue is y equals tangent of x. Now let's do green. And all I'm going to do now is just switch the points. Well, 0 is still going to be 0, so that's no big deal. Now I will have horizontal asymptotes. Yes, you must graph out your horizontal asymptotes. Okay. Now, remember, we had a dot at pi over 4, comma 1, so now it's really 1, comma pi over 4, like there. Then we had a dot at negative pi over 4, comma negative 1, so now it's really negative 1, comma negative pi over 4, which is 2, 2 right there. Now, the original was hugging the y-axis, so this one you really want to hug the x-axis, okay? Okay, just like that. Now, in the perfect world, what if I couldn't graph this perfectly, it should, again, reflect about our line here of y equals x. So the red line is really y equals x. And